All right, we've got two more left from the quiz. I started these a couple times in between. One, I found an error on 2b. Um, uh, this second equation should be y equals negative x plus 4. It's written as negative 2x. If you do it as negative 2x plus 4, it's still possible to solve it, but the boundary points you get, at least the one boundary point you get, is super awkward, and that was not the idea, to have it be terrible like that. That obviously was not what I was going for, and it's just because I made a mistake typing it up. So I'm doing a solution for negative x plus 4. Hopefully you guys are watching this before you've gotten too far into it. In any event, so I started one video, found that mistake, restarted it, and then my animal started jumping up and getting into frame. So this is attempt number 3, and I just wrote everything out in advance. So I'm just going to kind of talk through it. I was trying to just like take away any surprises or anything else that could go wrong. So the solution here is written up, and we'll sort of talk through it. The lines we're working with here in 2b, y equals, root of 2x, y equals negative x plus 4, not negative 2x. And then the third one, x equals 0. That x equals 0 is probably going to be one of the boundary points. I did a quick sketch of everything. You could do this in Desmos. You can kind of do it by hand. In theory, to kind of find these intersection points, they're going to intersect at x equals 2, and then x equals 0 is going to be your sort of second boundary point. I kind of just freehanded this a little bit, right? Root of 2x, you could say, root of x is our typical kind of sideways parabola, 2 times x underneath. You've got 0, 0, you'd have kind of 1/2, and you'd hit 1, and then at x equals 2, 2 times 2 is 4, root of 4 is 2, right? So you kind of get a little bit of a compressed version of the root of x. And then negative x plus 4, right, starting at positive 4, y is 4, and then just sort of down 1 to the right 1, down 1 to the right 1. And you run into the other function pretty quickly there. So just a quick sketch. We know we want this region to the left versus whatever would happen over here, because the third boundary point is x equals 0 as a line. So the x equals 0 is here. So the only thing with sort of those three as a boundary altogether would be the part that I've shaded in. So the integral, right, that we're going to set up is, right, the upper function is the line, negative x plus 4. The lower function is going to be the root function, the root of 2x. And then the interval is going to run from 0 to 2. So 0 to 2, we've got, quantity x, negative x plus 4 minus root of 2x. The other thing here that happens that's a little bit different, there's just all sorts of tiny little sort of details in this one that make it tricky, is you have sort of half of this needs a u substitution and the other half doesn't. So it's root of not just x, but root of 2x. So what happens there is you need to do a u sub, but only for that last bit. So I'm actually breaking this up into two integrals, right? Negative x plus 4 you can just do with the normal routine. The root of 2x needs a u substitution, so you need to let u equal 2x. The derivative is 2, so you get this dx is, right, like du over 2. Right, so you're just getting some of that stuff that's different. This, of course, makes things a little bit more complicated. It kind of means you can't necessarily do everything in one. As I'm doing it here, I'm sort of just breaking this up into two different integrals. You can do that. That's sort of a good option if it seems like, in theory, you have some stuff where you need one technique on one piece and another on the rest of it. Just break the integral up. That works for doing the area stuff in the different integral anyway. So that's kind of what I'm doing here. I've got the quick antiderivative, right? Negative x plus 4, negative, right, 1/2 x squared plus 4x. And then this is where I'm starting to do my u substitution. This is pretty much just the trivial u sub. This is the sort of ax, right, style inner function. So your derivative is just the 2. So then your antiderivative, you really are kind of just doing a power rule, but you get this sort of 1/2 left over. So what I'm trying to do here, right, is I've got the antiderivative for this. We'll just sort of keep that paused for now. We'll do the antiderivative of our u sub right? 1/2 comes out in front. U to the 3/2 divide by 3/2 is going to be, right, 2/3 times 1/2. This original U, of course, was 2x to the 3/2 from 2 to 0. Careful here with your boundaries. I'm because this is x from 0 to 2. I'm kind of leaving this here as x from 0 to 2, and I'm just waiting until I get the x subbed back in. You could do what we did in previous videos over here and actually sub in, well, if u is 2 times x, you know, if the x is 0, the u is 0. If the x is 2, the u is 4. You can do that. That also works. In the end, right, what starts to happen for us here is, right, -1/2, just sort of subbing these values in. So I'm doing, right, -1/2 x to the 2 plus 4x, right, from 2 to 0. So I'm subbing these in here, right? So here are the 2's, here are the 0's. The 0's are going to make this whole piece go to 0. 4 times 2 is 8. 2 squared is 4, right? Times the -1/2. We'll deal with that. My second value here, so subtracting everything in here, right? So there's just a lot of moving pieces that are happening. So subbing 2 into here, 2 times 2 is 4, right? This is sort of the root of 4 cubed with the 1/3 in front, right? 1/2 and 2/3, of course. Minus subbing in the 0, 2 times 0 is 0, so that guy's going to end up being a 0. In any event, what we're going to end up with here in green, as we go through kind of all of these steps, right, -1/2 times 4, right, here's my 4, right, plus the 8 minus 0. This is going to be, right, root of 4 is 2, 2 cubed is 8, so that's 8/3 minus 0. We're subtracting that away, so this is going to end up in the end at 10/3 if we just sort of clean up all this stuff, right? Of course, 1/2 and 4 is 2, so -2 plus 8 minus this 8/3. This would be 6 minus 8/3. Get them all over the same thing, and we're good to go. So that's the basics of it, right? That's the idea. Sorry to sort of do this a little bit of a different way. I'm just sort of talking through it maybe a little faster, just because I sort of wanted everything out in advance. I did the same thing for number 3 again, or I'm sorry, 2C, letter C. Just sort of trying to sort of do everything and get it set up in advance. This one is one where you need to rewrite it. The kind of giveaway here is you're initially given this x equals y squared minus 2. If you're given any kind of x equals, probably that means you're going to have to do this with respect to y, and you're going to want all your graphs and pieces to be written as x equals. Quick sketch again, right? So y squared minus 2. So this is just sideways parabola, right? Or if we, turn it, you get sort of the regular parabola, right? Y squared minus 2, it's sort of down by 2. In this case, it sort of looks like it's the parabola, the sideways parabola shifted left by 2. The second line is y equals -x. So from our usual perspective, right, that's just going through the origin, right, down 1 to the right 1, down 1 to the right 1. And you can see pretty quickly the intersection points here are going to happen, from the x perspective at -1 and +2. But if I want this from the y perspective, which I really do because, from the x perspective, oh my gosh, sorry to be flipping this back and forth. From the x perspective, I have kind of 2 different regions and 2 different things happening. I have an upper and a lower here from like -2 to -1. And then I have a whole nother thing with a line over top, right, from -1 to 2. It's a different stuff. If I want it with respect to y, right, then my boundaries are the -2y, right, to the +2y, and we're going from there. Oh, no, it's not. It's not 2 to 2 at all, is it? Actually, I'm going to have to correct this as we go. This is -2, but the other value here is y equals +1. It doesn't go from 2 to 2. It actually goes from 1 to 2. Let me see if I can rewrite this on the fly so I don't have to redo this video yet again. Boy, math, sometimes a little tricky. So the integral here, right, goes from -2. So the change is that should be a 1, right? The boundary there, right, is y value 1 down to y value negative 2. The upper function, right, kind of the function on top was the linear function, so that's x equals negative y. If we just rewrite that, rearrange it, the original was y is negative x, so if you solve that for x, it just means that x is negative y, right? You're sort of just multiplying by negative 1 to flip where the negative lives. Pretty reasonable antiderivatives here, right? This is just sort of distributing this negative, right? Going from there. Antiderivative, not a big deal. Again, let's change these boundaries. So that should be a 1. This should be a 1. So what have I got? Let's keep it going. So all these numbers, if I'm subbing these in, these should be 1s instead of 2s. And then everything here should be negative 2. So that's going to change some of these values. So this is just a bunch of fraction math, a bunch of sort of arithmetic to clean up. Again, I'll try to just clean this up in real time a little bit. So this should be what? 1 squared is 1, so that should be negative 1/2. 1 cubed is 1, so that should be minus 1/3. These are fine. So what am I really dealing with here? Minus 1/2 minus 1/3 plus 4. Minus 1/2 minus 1/3. This stuff still cleans up okay, right? Negative 2 goes in, so then that's going to be a minus 2 plus 8/3 minus 4. So that's like a minus 6, but then it's a plus 6. And it's minus 8/3. So what did we say? This is 4 minus 1/3, but then also minus 1/2. So what is that? 10? This stuff is just not going to be useful anymore. Oh my gosh. These last couple videos just a little cursed, I guess, today. So this is 4 and 6, right? So that's 10. This is minus 1/3 minus 8/3. That's minus 9/3, which is going to be minus 3. And then the whole thing is minus 1/2. So this is 10 minus 9/3 minus 1/2 is 10 minus 3 minus 1/2. So that, right, 7 minus 1/2, 6 and 1/2, or 13 over 2. Goodness. In any event, the big things here as I'm grading these, I'm going to be looking a lot more at the setups, the details of some of this fraction stuff. You know, it is what it is. Obviously, you want to make sure you're doing all those steps right and getting them correct. That's the basics of it. So apology for that error, right? Again, we sort of clean this up. The boundaries here go from -2 to 1, not -2 to 2. And then that affected all these different things. But sort of the initial setup, you know, the big thing here is kind of getting, you know, if you have one takeaway from this part C, I would say it's this, right? The graph, getting to this picture. That's kind of the best stuff. In any event, eventually, right, those were the solutions for the practice quiz. Enjoy, and we'll keep going with some more stuff after that.